myself, Dr. M. Keshavulu, RASAAYANA Institute of Sciences. So we are offering JEE Mains, Advanced, NEET and Foundation programs. So we will provide in-depth content and problem solving ability and also logical skills to solve the various numerical problems and as well as conceptual problems. So even we have covered from basics to even depth level up to advanced level, right? So in that, so we know about, so chemistry means there are many reactions will be there, right? So if any reaction is carried out, what information we are getting from that reaction, whatever is the reaction we may consider. So for example, a photosynthesis reaction is there. So from that, what is the information we are getting with the help of a chemical reaction, right? So we are saying that a reaction is carried out, right? So means the reactant molecules are converted to the product. In some cases, the products again come back to form the reactants. Means, so two type of reactions will be getting. So what is the information we are getting from that reaction? Whether the reactants are converted to the products and the products are converted to the reactants. The information we are getting that can be explained with the help of the topic was equilibrium, right? So the topic is equilibrium. Equilibrium means the reaction, a general reaction we have to consider. General reaction. So that general reaction means reactant molecules are converted into products. This reaction may be carried out with the help of catalyst or with the help of temperature. With the help of catalyst or with the help of temperature. So what are the reactants and what are the products, right? So this is a chemical reaction. In this chemical reaction, the substance which enters into a chemical reaction. The substance which enters into a chemical reaction, that is called reactant. So the substance which is formed in a chemical reaction, that is called products. So the whatever is the substance that will be entered into the reaction, that is known as reactant. So whatever is the substance that can be formed in a reaction, that is known as products. So whatever is the reaction is carried out from reactants to products in only one direction, that is called irreversible reaction. So if in some cases reactions, products also will be converted into reactants. So means both the manner reactions are carried out. So that is a forward reaction and as well as backward reaction. So during this reaction, that reaction is known as reversible reaction. In that reversible reaction, we are going to getting the state or condition that is called equilibrium, right? So these are about reactants and products, right? If the reaction is carried out, means the reactant molecules are converted into products. Reactant molecules are converted into products and products also converted into again form reactants, right? So these reactants and products are concentrations will be same at one particular condition, that is the condition is known as equilibrium. Then why we are going to study about that equilibrium? So there are various applications regarding this equilibrium. Even this we have to apply in biological concepts, right? So in industrial and as well as in environmental, right? So whatever is the biological, if we may discuss, the concept of equilibrium is applicable for the biological. So simply hemoglobin is combined with oxygen, so we will get oxyhemoglobin, right? So this hemoglobin, so this is, so even this oxyhemoglobin so dissociates into again hemoglobin and oxygen, right? So how we are utilizing that oxygen? So initially hemoglobin absorbs oxygen, then converted to oxyhemoglobin. So further this oxyhemoglobin will produce oxygen. So this is the biological system, so in which we are getting the conditions from reactants to products and products to reactants. So that is the one of the application, right? So even industrial application will be there. So there are various industrial applications. If we are going to synthesize the ammonia, that is nitrogen and hydrogen. So this nitrogen and hydrogen will be involved to form ammonia. So 1 mole of nitrogen, 3 moles of hydrogen to give 2 moles of NH3. So this is the industrial application. So we have to utilize the synthesis of ammonia by Haber process with the help of various catalyst and conditions of temperature and pressure, right? So that will give a equilibrium condition, right? So these are the somehow applications. So many reactions are involved. That condition is the equilibrium. So right, what is meant by equilibrium means the state at which so the reactants and products concentrations are equal. So or else the rate of reactants is equals to rate of forward reaction is equals to rate of backward reaction. So this is meant by forward reaction. Reactants are converted to products, then products are come back to reactants, that is the backward reaction. So we use it to utilize the two conditions. One is the concentration and other one is the rate. So with the help of that we are going to explain the equilibrium, right? So the equilibriums will be two types, right? So equilibriums will be two types. So one is reversible and irreversible, right? Generally reactions are reversible reactions and irreversible reactions, right? So what is meant by reversible? So then what is meant by irreversible? Right. So whatever is the reaction is carried out in both the manner, right? So both the manner the reaction should be takes place, both manner. That means forward reaction and as well as backward reaction. So such reactions are what? Reversible reactions. We will get the equilibrium condition in case of reversible reactions. What is meant by irreversible means which will be takes place in one direction only. One direction. That means reactants are simply converted into products. So no other direction products are not come back to form reactants. So that is the irreversible and this is the reversible. So if we able to discuss the examples of reversible means, so one will be there, that is the synthesis of ammonia, N2 plus 3 moles of hydrogen which gives rise to ammonia, 2 moles of ammonia. So these all are gaseous, right? So this is the equilibrium means by combining of N2 and hydrogen, nitrogen and hydrogen to form ammonia, and ammonia also dissociates into H2 and N2. So this will be happened in a closed vessel. This should be happened in a closed vessel. Means the equilibrium condition or reversible reactions will be takes place in a closed vessel, right? So in irreversible, that is the decomposition of KClO3, potassium perchlorate. So this KClO3 upon heating that becomes converted to KCl plus oxygen. So if you have to apply the stoichiometric condition 2 moles, this will be 2 moles and 3 moles of oxygen. So here the dissociation of KClO3 will produce as KCl plus oxygen. This won't get to form again KClO3. This is only one direction reaction, that is known as irreversible reaction. So these irreversible reactions are occurs in open vessel, right? So then, so this is the equilibrium condition means, so it will be not applicable for completion of the reaction means, so somehow reactants are converted to the products and products again converted to reactants. Simultaneously, if concentration of product will be more, so definitely backward reaction will be takes place. Therefore, so there is attainment of equilibrium between them. If reactant concentration will be more, so there somehow forward reaction will be carried out and attainment of equilibrium. Therefore, there is no completion of reaction. No reaction should be completed. No completion of reaction in this case of reversible, right? There is a 100% reaction is completed. 100% reaction is completed, because only one direction will be there, so that is reactant is gives rise to product, right? So therefore, what is the condition means we have to apply the condition of equilibrium. So the reaction should be carried out in a closed vessel, and which won't give a complete reaction, right? So if concentration of reactants will be more, that forward reaction should be favored. Concentration of products will be more, backward reaction will be favored to attainment of equilibrium between both reactants and products, that is called equilibrium, right? So that equilibrium should be explained with the help of a simple graphical phenomenon, right? So then for a general reaction, right? So for a general reaction, what is the graphical representation of equilibrium, right? Equilibrium graphical representation for a general reaction, reactants are converted into products, and also products are converted into reactants. At initial stage of the reaction, only reactant molecules will be there, whose concentration should be very high. So if we have to take concentration of reactants or else products, that will be concentration on y-axis and time will be on x-axis. As the time is going on, initially only we have reactant molecules, right? No products are formed at initial stage. As the time is going on, somehow reactants are converted to the products, right? So this is the forward reaction, right? This is the forward reaction, and this is the backward reaction. So in terms of concentrations, initially reactant concentration should be very high. So as the reactant concentration will be decreases with respect to time, so that is the R. At the same time, as the concentration of reactant decreases, the product concentration will be increases. So therefore, the product concentration will be like this. So this is the product concentration that will be increases, right? So we consider the condition. At that condition, both the product and reactant concentration should be equal. That is the condition is known as equilibrium. That is the condition is known as equilibrium. Concentration of reactants is equals to concentration of products, where the condition both the concentration of reactants and products are same. That is the condition is known as equilibrium condition. Even in addition to this concentration, with the help of rate of reaction also we have to explain, right? So if we consider rate of reaction, that is with respect to time, right? Rate of reaction with respect to time. So that means as the reactant concentration will be decreases, means its rate will be decreases like this. So this is about reactants molecules, right? So at the same time, the product rate will be increases. These both are same at one particular condition. So that is the condition is known as equilibrium. This is the condition is known as equilibrium. So that means even we have to express with the help of rate and with the help of concentration. Say with the help of concentration, the condition or state at which the concentration of product is equals to concentration of reactant, that is known as equilibrium. Or in terms of rate, so the rate of forward reaction is equals to rate of backward reaction. So this is the forward reaction rate and this is the backward reaction rate. So both the rates are same at one stage. That stage or state is considered as equilibrium. So this is the equilibrium expressed in the form of graph, right? So even this we have to apply for a simple reaction. So simple reaction, ammonia will be there. Synthesis of ammonia from Haber process. So that is nitrogen and hydrogen will be there. So even we have to apply these concepts to the example. That is nitrogen plus 3 moles of hydrogen. So that will be converted to 2 moles of ammonia. Gas, then gas. So the reactant molecules are nitrogen and hydrogen, and product will be ammonia, right? So therefore, if you consider the concentration versus time, right? So concentration versus time or rate versus time. So nitrogen will be, hydrogen will be like this. This is the concentration of hydrogen, right? So then, so again the concentration of nitrogen will be like this. So these reactant molecules concentration will be decreases and product molecule concentration will be increases. So this is belongs to NH3. So reactant concentrations will be decreases and product concentration will be increases. At one condition both the concentrations are equal, that is the condition is known as attainment of equilibrium. So whether the equilibrium is formed or not of this particular reaction, even that can express with the help of thermodynamic properties also. So with the help of thermodynamic properties, right, the change of thermodynamic property from reactants to products. So many properties will be there. One of the property, that is delta S, that means S for entropy, the change of entropy is equals to 0. That is the condition is known as equilibrium condition. So not only the entropy, even enthalpy change also becomes 0. Delta G also becomes 0, gives free energy. Then delta A also becomes 0 and internal energy delta E also becomes 0. So means the change of thermodynamic property becomes 0 whenever the reaction is carried out, reactants to products and product to reactants, the thermodynamic property change becomes 0. That is the condition is known as equilibrium condition. So even this all are equilibrium conditions. Right. So this is in terms of thermodynamics point of view. In terms of thermodynamic point of view. So these are, so just representation, with the help of graphical representation we are able to understand the equilibrium. Then the conditions were rate of reactants is equals to rate of forward reaction is equals to rate of backward reaction, reactant concentration is equals to products concentration. These two conditions are considered as equilibrium conditions, right? Equilibrium conditions. So there are two type of equilibriums will be there, right? Even this is the condition we have to apply for the various physical processes and as well as chemical process, right? So the condition means reactions are carried out. In some cases physical changes are occurs, in some cases chemical changes are occurs. Therefore we have to apply this equilibrium to both physical and as well as chemical processes. We have to apply this equilibrium to physical processes and chemical processes. Physical process and chemical process. What are meant by physical processes? Means there is a phase change will be there. So from one phase to another phase. That means solids are converted to liquids. Therefore solids are equilibrium with liquids. The equilibrium concept is applied between the solid and liquids, right? Where the condition, so the solid concentration is equals to liquid, or else the rate of forward reaction is equals to rate of backward reaction. That is the condition is known as equilibrium. So then liquids are converted to gases. These all are physical processes. So then solids are converted to gases. This is a sublimation process, right? So this is a fusion process and this is the vaporization process and this is a sublimation process. These all are physical processes. So the equilibrium condition is applicable for all type of physical process and even say chemical process, right? So any chemical reaction will be there, right? So for example, so that is CaCO3 dissociation upon heating. So that is the solid substance that will be converted to CaO plus carbon dioxide. This is the gas and this is the solid. And one more reaction will be there, N2 plus 3H2, which gives rise to means which is equilibrium with 2NH3. This is the gas and gas. So these are the physical states, right? So what are the physical states that should be mentioned in the bracket that we have to discuss in law of mass action and a law of chemical equilibrium, right? So these are the equilibrium is applicable for all type of physical processes and all type of chemical processes. Chemical changes will be there. So from reactants to products. So then we have to apply the condition is known as equilibrium. So here we need to observe one thing. So here some physical states will be different in reactants and products, and physical states will be same in reactants and products. Therefore, so those equilibriums are, we have to explain in two types based on the physical states. So based on the physical state, if the equilibriums are two types, right? So based on the physical state, equilibriums are two types. Based on the physical state, equilibriums are two types. One is homogeneous equilibrium, and the other will be heterogeneous equilibrium. So what is homogeneous equilibrium? What is heterogeneous equilibrium? Right? So in a reaction, both reactants and products are present in same phase. Both reactants and products are in same phase. Both reactants and products are in same phase. That is, the equilibrium is known as homogeneous equilibrium. In a equilibrium, both reactants and products are present in same phase. So for example, here N2 plus 3H2 gives rise to 2NH3. Here reactants are in gaseous phase and product also in gaseous phase. Both are present in same phase means, so this is the equilibrium is known as homogeneous equilibrium. So in heterogeneous equilibrium, so reactants and products are present in different phase. Reactant and products are present in different phase. So one will be reactant, suppose reactants are in solid, so the other phases are present in the products. So this is the example for heterogeneous. Calcium carbonate is converted to calcium oxide plus carbon dioxide. Carbon dioxide is the gaseous phase and calcium carbonate is the solid. So therefore two different physical states are present in reactants and products. Therefore this is the example of heterogeneous equilibrium. So with the help of equilibrium, we able to get the equilibrium constant. With the help of equilibrium constant, so we able to get huge information regarding about the equilibrium, right? So main we have to remember, so that equilibrium will be the process. Equilibrium will be takes place in a closed vessel only. In open vessel we won't get equilibrium, because so somehow products will be gases, means that will be enters into the environment with the help of open vessel. So whenever whatever is the closed vessel is there, we have to run the reaction. So that reaction is attaining of the equilibrium condition. So even there is no completion of the reaction in a closed vessel, right? So such equilibriums are even we called reversible reactions, right? So this is the types of equilibrium. So then here we need to apply the two laws, right? So means one is the law of mass action, and other one will be law of chemical equilibrium. So we have to apply the laws. The first one will be law of mass action. Law of mass action. In a general reaction, reactants are equilibrium with products, right? In a general reaction, reactants are equilibrium with products. Whatever is that reaction, so either we have to consider a forward reaction or we have to consider a backward reaction. So in case of backward reaction, these products are acts as reactants. In case of forward reaction, reactants are acts as reactants only, right? So whatever is that, we have to apply the law of mass action. What is meant by law of mass action? Law of mass action, right? So the rate of reaction is directly proportional to rate of reaction is directly proportional to product of concentration of reactants, product of concentration of reactants or active mass of reactants, active mass of reactants. Rate of the reaction, we are able to get the rate of the reaction with the help of applying of law of mass action, right? So for example, we consider one example, right? A plus B is gives rise to products, whatever is the products, right? So if we consider a forward reaction only, right? So forward reaction means the rate constant will be Kf, the backward reaction means that will be Kb. So even if we consider the backward reactions means we have to take the products also C and T, right? So what is the law of mass action, right? So the rate of forward reaction, the rate of forward reaction is directly proportional to concentration of the reactants. What are the reactants here? Concentration of the reactants means that is concentration of A and concentration of B. So this is the rate of forward reaction is directly proportional to the concentration of the reactants or active mass of the reactants, right? So concentration of the reactants or active mass of the reactants. So if you consider the reverse reaction, so what about rate of backward reaction? Rate of backward reaction means C plus D is converted to A plus B. Whenever we have to write that reaction, C plus D is gives rise to A plus B. At that time C and D are the reactants. Therefore in this backward reaction, so we get concentration of C and concentration of D. So what is the condition of equilibrium? What is the condition of equilibrium? This proportionality can be replaced with some constant. Proportionality can be replaced with some constant. So here the active mass will be denoted with N by V, and also that will be denoted with concentration or active mass will be represented with a square bracket, right? So this is the what? Square bracket. The reactant's active mass, that is N by V. So the concentration will be, that will be square bracket. Means this is a square bracket will indicates the concentration or active mass of the reactants. So the rate of forward reaction is directly proportional to the two reactants are there. That's why we have to consider the product, right? Two reactants are there. That's why we have to consider the product. So therefore the product of reactant concentrations and rate of backward reaction is directly proportional to concentration of C and D. And also that is also directly proportional to active mass, right? With the help of this active mass, we able to get the law of chemical equilibrium. So what is meant by law of chemical equilibrium, right? So with the help of law of mass action, so we will get law of chemical equilibrium. Law of chemical equilibrium. Right. So what is meant by law of chemical equilibrium means at a constant or at instant given temperature, the ratio of product of concentration of products to the ratio of product of concentration of products to product of concentration of reactants, at which the stoichiometric coefficients can be considered as a powers of this, at which stoichiometric coefficients stoichiometric coefficient should be taken as powers. Stoichiometric coefficient should be taken as powers. So this is known as law of chemical equilibrium. For example, a general reaction will be carried out. So what are the coefficients of reactants and products? Those coefficients can be considered as a powers, and also we are able to write the ratio, that is product concentration of products by product of concentration of reactant, that is known as law of chemical equilibrium. So with the help of this statement we have to apply one general equation so to this law of chemical equilibrium. From that the equilibrium constant we will get, right? So we'll consider A moles of reactant A, B moles of reactant B, so which is equilibrium with C moles of reactant C plus D moles of product D. C and D are products, A and B are reactants. Small AB and CD are the coefficients of reactants and products. These are the reactants and these are the products. So according to this we have to consider, right, first we have to apply the law of mass action. So what is meant by law of mass action means rate of forward reaction. Rate of forward reaction is directly proportional to reactant concentrations or active mass of the reactants, that is A and B. So reactants are capital A and capital B, and small ab are its coefficients. With the help of law of chemical equilibrium, so these can be reactant concentrations A and B, and whose coefficients should be considered as powers. This is about forward reaction. So similarly we have to apply backward reaction. This is the forward reaction and this is the backward reaction. For backward reaction, at that time these C and D are acts as reactant molecules, that will be converted into again A and B. So therefore the rate of backward reaction is directly proportional to concentration C power C and D power D, right? So these small c and d are the coefficients of C and D. These C and D are acts as reactants whenever we are going to discuss about backward reaction. So whatever is the condition at equilibrium, right? So at equilibrium, the both rate of forward reaction is equals to rate of backward reaction. Rate of forward reaction is equals to rate of backward reaction. So what is this rate of forward reaction? That is directly proportional to active mass of the reactants. Then in backward reaction, so rate of the backward reaction is directly proportional to active mass of the C and D, right? So therefore rate of forward reaction we have to write. So from this, so the rate constant for forward reaction is Kf, for backward reaction is Kb. Therefore whose rates will be Kf of A power A and B power B is equals to Kb of C power C and D power D, right? So therefore we are able to rearrange this Kf by Kb. Kf by Kb is equals to C power C and D power D divided by A power A and B power B. This Kf by Kc, that ratio we have discussed here, the law of chemical equilibrium. So that is the ratio should be considered as equilibrium constant, that is Kc. So what is the equilibrium constant that can be explained with the help of law of chemical equilibrium means, here in this reaction C and D are the products, product active mass or concentration, and power we have taken their coefficients as the power, then divided by reactants are A and B, and those coefficients should be considered as their powers. So this is the law of chemical equilibrium. Therefore Kc is the equilibrium constant. Equilibrium constant. right? So as we mentioned that so many physical processes and chemical processes will be there. So physical processes means there is a different phases are present, right? So one phase is converted to the other phase, right? So then with the help of all the phases, which phase we have to consider to apply that equilibrium constant, and so which phases we have to take constant, that is depending on the substance which is involved in the chemical reaction, right? So therefore, so these concept we have to apply for the general reactions, that is the equilibrium constant Kc. So what is the definition of this? Means the product is nothing but two reactants are there, C and D. The product of concentration of products and their coefficients written as powers by product of concentration of reactants and whose coefficient should be taken as powers, right? So that is the law of chemical equilibrium. This we have to apply for the various equilibrium reactions. We are able to get equilibrium constant, that is Kc. This Kc is expressed in terms of concentrations, right? Whether the reaction is involved in the gaseous molecules, so therefore even we have to consider the pressure for those gaseous molecules. So therefore we have to apply this condition to the gaseous molecules. In place of Kc we have to take Kp, and also we are able to get the relation between Kc and Kp, right? So if it is a gaseous molecule, right? So if it is a gaseous molecule, so means in this reaction the physical states also expressed in brackets at their places, right? So means whatever is the reactant, what is its physical state, whether it is a solid or liquid or gases, even we have to express. That is also mentioned in the law of chemical equilibrium, right? So example, for a gaseous reaction, the reaction should be involved in gaseous reactants and gaseous products, right? So that is A plus B, whose physical states are what? Gaseous only. So here the P and Q, so which is equilibrium with C plus D, right? So here MC and ND, right? So this is also what? Gaseous only. Means all reactants and products are gaseous, therefore we have to apply the concept of law of chemical equilibrium. Instead of Kc we have to consider as Kp. Kp is the equilibrium constant. So then reactants and products are expressed in their partial pressures. Therefore this is the product's partial pressure of C power m, this is the coefficient, into partial pressure of D power n, its coefficient, divided by partial pressure of reactant A, whose power will be P, and partial pressure of B, whose power will be Q. So means, so those concentrations will be expressed in terms of pressures. So when the reaction is a gaseous, we have to consider the pressures. Therefore at that time we have to consider the equilibrium constant, that is in terms of partial pressures. So this is Kp will be equilibrium constant in terms of pressures, right? So this is in terms of concentrations, that is the Kc. In terms of concentration, that is equilibrium constant is Kc. In terms of pressures, that is known as Kp. So this Kc Kp relations we have to apply for the various reactions, and we are able to get the relation between them also, right? So then we'll see. Here we need to remember that, so there is a important note, right? Means for what we have to consider pressures and we have to consider concentrations, right? So what is meant by note? Means for solid substances or pure liquid substances. For solid substances or pure liquid substances, for solids and for pure liquids, active mass, this is also nothing but concentration. Active mass or concentration or partial pressures will be considered as unity. That means 1. So important note, whatever is the solid substance is involved in equilibrium, so for that its active mass or concentration will be considered as unity, and if it is a pure liquid whose concentration, partial pressure or concentration will be considered as unity. Whenever gaseous molecules will be there, definitely we have to consider those gaseous molecules in that particular reaction to get equilibrium constant, right? So we are able to discuss 2 examples, right? So one example will be, right, so PCl5 of gas is dissociates into PCl3 plus Cl2. So this is the gas and this is the gas molecule, means all are gases. So therefore we have to get the Kp and Kc values, right? How will write the Kc and Kp values? Kc means equilibrium constant in terms of concentrations. We have to apply the law of chemical equilibrium. So here the coefficient will be 1 only. Here the coefficient is 1. Here the coefficient is 1. Therefore, product's concentration we have to take first. The product will be PCl3 and Cl2. These are the products whose coefficients are 1 1 only. So whether we have to write or no need to take the 1. PCl3 concentration into Cl2 concentration divided by PCl5 concentration. So the same we have to apply all our gases only. Therefore we have to apply the Kc value, Kp value in terms of partial pressures. So the partial pressure of the products means what we have to consider here. So that is partial pressure of PCl3 into partial pressure of Cl2 divided by partial pressure of PCl5. Always numerator is the belongs to products, right? So how many products here? 2 products are there. So that's why pressure of 2 products divided by 1 reactant is there, 1 reactant. So this is the representation of Kc and Kp for the equilibrium reactions. Here no issue because all are gases only. So directly we have considered concentrations and as well as partial pressures of gases. But whenever solid substances and liquids are there, at that time how will get the equilibrium constant? Right? So that will be expressed in terms of concentration and as well as pressures. So that we'll see by considering one more example, right? So that is example number 2, right? So here all will be there. So then one reaction, that is calcium carbonate is equilibrium with calcium oxide plus carbon dioxide, right? So what are the physical states of those substances? We have to express in their bracket. This is the solid and this is the solid and this is the gaseous, right? So how many substances are there? So here reactants are solids and products will be solid is there and gas is there. How will get Kp and Kc for this particular reaction? Kc is equals to concentration of products. In products, solids concentration will be here only. For solids, what is the concentration or active mass? That should be considered as unity, right? So therefore, this is the unity. The remaining will be concentration of CO2. Then divided by remaining reactant also solid. Therefore, no need to consider, only this is the Kc value for above reaction. So in case of Kp, we have to utilize the partial pressures. So the pressures which will be applicable for gases only, remaining solids and pure liquids. For solids and pure liquids whose partial pressures will be considered as unity. Therefore, this is the solid whose partial pressure will be 1 and this is the solid whose partial pressure will be 1. Therefore, only we have to consider the pressure, partial pressure of CO2. Partial pressure of CO2. So this is the only representation of Kc and Kp. So that we have to apply for the various substances like solids, liquids and gases, right? So for solids and liquids, pure liquids whose concentration or active mass or partial pressures will be considered as unity. The remaining we have to consider as usual which are present in the reaction. right? So this is the equilibrium constants will give the information. What type of information it will give means whether the forward reaction will be takes place or backward reaction will be takes place or attainment of equilibrium. So with the help of that, whether the reaction is completed or not completed, and all those things. If we have to complete that reaction, what are the conditions we have to utilize, right? And also the equilibrium constant, the factors, only one factor that can be varies equilibrium constant, that is the temperature only. The remaining all are constant at equilibrium process, right? Only one factor, that is the temperature, that can be varies equilibrium constant. The other properties will be there like pressure and catalyst and mass and some other will be, these all are constant at equilibrium. There is an effect of temperature on equilibrium. If the temperature will be rises, what happened that equilibrium? So that we have to explain with the help of application of Le Chatelier principle to the equilibrium constants, and also we will get the relation between the Kc and Kp. Equilibrium constant is expressed in terms of concentrations and equilibrium constant expressed in terms of pressures, and what is the relation between them. So that relation we will prove, and so we able to apply all those relationships, and we able to get the numerical questions from this equilibrium topic in advanced level. Also we able to discuss the relation between the Kc and Kp, how they are related with each other with the help of number of moles. That number of moles will be applicable for the gas reactants molecules and product molecules, particularly in gases. With the help of that, so whether the Kp value will be more or Kc value will be more, or it is a equilibrium condition, or other than the equilibrium condition, that is the reaction coefficient, what is the relation between them, all those things information we able to get from this equilibrium process. So somehow problems and so remaining topic we able to discuss in the next class.